Welcome to our second tutorial on MATLAB. We are going to introduce you to matrices. So if you have to assign a matrix A, so use a variable A and then equal to, in the square bracket you will enter the values and separate the values in different rows by a space or a comma, and then separate the rows with semicolon. So like 1 2 3 semicolon 1 2 3 semicolon 1 2 3 will give you a matrix of order 3 cross 3. Number of rows are 3 and number of columns are 3. So matrix A has this value 1 2 3 1 2 3 and 1 2 3. So if we had terminated the statement with semicolon, so that value would not have been displayed in the command window and it would have been only assigned in the workspace. Now let us perform some operations on matrices, and for that let us assign another matrix B which is of same order as A. So the matrix B is 157 semicolon 689 semicolon 790. So the matrix B also has the order 3 cross 3 and A also has order 3 cross 3. So we are going to do the first operation as addition and simply add them as normal variables A plus B, and this will result into the addition of the two matrices. So you can verify the results. For the next matrix operation is matrix multiplication with a scalar, and let us assign a scalar with value 2. Now we are going to multiply matrix A with the scalar k. So for that, k asterisk A is the command, and each value of matrix A has been multiplied with scalar value 2, so the values have been doubled, and simply you can use the asterisk operator for scalar multiplication. So if you had to multiply two matrices A and B, then use the operation A asterisk B. For matrix multiplication, the dimensions must agree, and the dimensions, that is the inner dimensions, must be equal. So number of rows in the second matrix should be equal to number of columns in the first matrix. Then only the matrix multiplication will be possible. Like if we assign a matrix C of order 2 cross 2, then the multiplication will not be possible. Like the matrix C has values 1 2 1 2, so A asterisk C will not be possible, and that will inner dimensions are not agreeing, so that is the error. If the dimension of C is 3 cross 2, then the earlier operation can be possible because the inner dimensions are agreeing, that is the number of rows in the second matrix, that is C, is equal to number of columns in A equal, so that is why that operation is possible. Vice versa is not possible because inner dimensions are again not agreeing. C has number of columns as 2 and A has number of rows as 3. So A cross C is possible, but C cross A is not possible. So C cross A will result into the same error, inner dimensions must agree. And let us clear our command window and let us move to next command. So for taking the negative of matrix is similar to multiplying the matrix with a -1 to that matrix, and it is similar to scalar multiplication. So simply you can do, if we want to negate matrix A, so simply do the operation A minus A, and all values have been negated, so each element has a negative value. In this way we take the negative of matrix. Now let us restore our values. So for that we again take the negative and the results are restored. So let us clear our command window. Now for taking the transpose of a matrix, we will use the apostrophe operator and it will transform the rows into columns and the columns will be transformed into rows. So you can visualize it. So we will show you the matrix A, and A has the values 1 2 3, 1 2 3 and 1 2 3, but the transpose of the matrix A has the values as 1 1 1, 2 2 2 and 3 3 3. So rows and columns have been interchanged. So if we have to take inverse of a matrix, that matrix should be a square matrix because rectangular matrices don't have inverse. For that we have the function inv and the argument is the name of the matrix and that will result into the inverse of that matrix. Over here all the values turned into infinity because the rows of A are same, but if we had some other matrix, so let us assign new values to A. So the new values are 1 2 3 4 5 6 and 7 8 9. So this will not give you infinite value because the rows are not same. So if we take the inverse of matrix A, still close to singular or badly scaled because we have not properly scaled the matrix. There is still a warning, but if you properly scale the matrix, then these warnings will not appear. So because for each square matrix there does not exist a inverse matrix. So take the matrices properly before taking the inverse of that matrix. So these were the mathematical operations on the matrices. Let us consider other operations. So we have already assigned the matrix A and matrix B, and that is visible in your workspace. The values to A are 1 2 3 4 5 6 7 8 9 and to B are 1 5 7 6 8 9 and 7 9 0. So if you want to apply the corresponding element multiplication, so use the operator dot asterisk operator and the elements will be multiplied element wise. A and B are over here and you can confirm the results. So first element of A is 1 and second element of B is also 1. So the first element of A and B product is 1 and you can verify the rest of the results. So A dot asterisk B will result into element wise multiplication. So we have cleared our command window and let us see another operator like dot and cap operator together. If we want to raise each element by a power of 2, we will use A dot cap 2. This will result into each element raised to power of 2. So you can see the values. Matrix A have been raised by a power of 2. Third element is 9 in A dot cap 2 and in A it is 3. So it has been raised to a power of 2. So similarly, want to take the square of the matrix, use the cap operator normally as you do for the other variables and that will result into the square of that matrix A. So for that only square matrix can be used. Now the function is size and this results the order of the matrix. If we want to know the size of matrix A, then that will return the number of rows and number of columns in that matrix. And now if we want to access any particular element of matrix A, like if we want to access the element 5, we will enter the locations like A location is second row and second column, so the values are 2, 2, and it will result into the value that we want to access. It will return the value 5. Now if we want to access the particular section of that matrix A, suppose we want to access the first two columns and all rows of those first two columns, then for that we will use the colon operator. The colon operator will gives you the range. For all rows we will use only colon, and then we will separate it by a comma, and see, since we want to access the first two columns, we will give the range as 1:2. The result is all the rows of first two columns have been accessed. So new matrix answer has been assigned 147 and 258 as the two columns. Now if we want to change the particular element, like the element at 2, 2, if we want to change its value, so simply we can do that by assigning a new value to that location. So if we do an operation like this, a 2, 2 is equals to 10, this will change the value at that location. So compare the earlier matrix and the new matrix A. So values have been changed at 2, 2. So value has been changed from 5 to. Now if you want to append the number of rows and assign a particular element to the second column of that new row, you can use simply like this: a 4, 2, and we want to give the value 13 at the fourth row's second column, so we will simply do is equal to 13, and doing this we will enter the value 13 at that position, but the rest of the elements of that row will be assigned the value 0. So you can visualize the results, and all other elements are 0 in that row. Fourth row has been created and the first and third element have values 0, and the second element has the value 13. So now array A has been transformed. Let us clear our command window. Now if you want to access the previously accessed command, so go to the command history tab, and if we want to reassign the value to matrix A, we will go to that command and double click on that command, and the matrix A has been reassigned. Now we will talk about the colon operator, which assigns the range of values. So suppose we want to assign a range of values from 1 to 10 in array A, so we will simply do A is equals to 1 is to 10. This will assign the values, equally spaced values from 1 to 10 with the spacing 1. So first element of A is 1, second element is 2, third is 3, and so on and so forth. But if you want to assign values which are equally spaced but the spacing not equal to 1, like if you assign a space of 0.1, then you do something like this: 1 is to 0.1 is to end element like 2. So if you want to assign the values up to 2, so 1 is to 0.1 is to 2, and this will assign the values which are equally spaced by 0.1. So 10 elements have been assigned from 1 to 2 with the difference of 0.1 into each of them. Now let us clear our command window once again. Now let us assign the value of A back to its original one. Now if we want to assign the element 5, so what did we do? We simply entered the position as 2, 2 and the value accessed was 5. Now let me tell you one thing. Here the indexing starts from 1. Unlike other programming languages, the indexing does not start from 0. Here indexing is from 1 for the rows, and first row is indexed as 1 and the first element of that array is 1, 1. That's all for today. Thanks for watching.